Hello! Can everybody hear me okay? I am Jetpack Jason. I am a mad scientist. Welcome to my online lab. I am super excited to share some fun experiments with you all today. But before we get started doing all this fun stuff, I do have 3 rules for us to follow. They're really, really easy, I promise, all right? My first rule is please, 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 only one mad scientist speaking at a time. In fact, you're on mute right now. If you have a question or something like that, we can type and comment and all that fun stuff. So please, 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 please stay muted at this point so that way everybody can hear everything that's going on with our fun show, all right? So my second rule is we can always ask questions. That's what science is all about, is we ask questions to figure out things. So if you have questions, you can feel free to type those in the comments, appropriate questions, type those into our comments, all right? And that brings me to my third rule, the most important rule, and it's my favorite rule. If you think you know what that third rule is, here's what I want you to do. Here's your opportunity to test out those fingers, and you can type in that third rule if you think you know what it is. I'm going to give you a hint right now. It's have fun. So on the count of 3, I need everybody to type have fun into the comments, and then that way we can have a ton of fun. Oh, there's more coming. All right. Well, I tell you what, with everybody here right now, we got to practice this so that way you all know that third rule. You guys ready? 1, 2, 3, type it in, hit enter. Woo! Yes! Thanks, Catalyst Courtney. All right, well, you know, I think it would be like really, really fun to get started here with, let's do a little bit of a magic trick. Now, while I do this, I want you guys to think about the difference between a magician and a scientist. Which one do you think I am? Am I a magician or am I a scientist? I'm gonna go with, oh, which one do you think? Let me see. What do you think I am, a magician or a scientist? Is that Heather? Am I a magician or a scientist, do you think?
Yes.
A what now? Say it one more time.
Scientist.
I think, well, what gives that away? Why would you think I'm a scientist? Maybe because I'm wearing a lab coat?
Yeah, and I know all scientists wear those.
Right, yeah. Well, I tell you what, so you're right. I am a scientist, and I love being a scientist. But you know what we're going to do? We are going to try out a little bit of a magic trick here. So I want you guys, while I do this, to think about the difference between a magician and a scientist, all right? So right here, I'm going to move this really, really close so you can see it. What does this look like I have right here? Maybe a piece of ribbon, right? Piece of string. Well, yeah, and it's kind of a nice pinkish color. So I tell you what we're going to do. Here's our magic trick. I'm going to take our one piece of ribbon, and I am going to take these pair of scissors, and I'm going to cut it right in the middle, right in there, and we have 2 pieces of ribbon. There we go. That's the magic trick. We turned 1 piece into 2 pieces of ribbon. Thank you. No, I'm kidding. That's a lame magic trick, isn't it? That is not that much fun. So I tell you what we're going to do. We're going to take these 2 pieces of ribbon here. We're going to cut these 2 in half. All right, let's see. We cut these 2 in half. Boom, like that. Then we end up with 4 pieces of ribbon. Now, I'm going to set these down right here. And I'm going to get right up here. Can you guys see anything in my bag here? Nothing hanging out in my bag. I don't see anything in there. Nothing in there. All right, cool. So we're going to stick our 4 pieces of ribbon in here. 1, 2, 3, 4. All right, and I need, actually, you know what I really need is a good magic word from somebody here. Is there anybody that has a really good magic word? All right, I think, is that Heather that has her hand up again? Let's see. Yeah. All right, can we, Heather, whoa, I unmuted the wrong person. Let's see. Awesome. So how many pieces of ribbon did we just put in there? Oh, you have a magic word, right? 4 pieces of ribbon. And what's your magic word for me? Abracadabra. I think that is a fantastic magic word. All right, so on the count of 3, I need you guys, everybody at home, I need you to just say it really, really loud. I need you to say abracadabra on the count of 3. I'm going to wave my hand over the bag. And if we do this right, we should wind up with all 4 pieces, like Heather said, all 4 pieces of that ribbon being tied. Who thinks this is gonna work? Raise your hand if you think it's gonna work. If you don't think this is gonna work, I want you to raise your hand. What? Oh, I love the thumbs up. Thanks, Courtney. And who has no idea what's happening? I want you to just go ahead and throw both hands up or do nothing. All right, fair enough. Here we go. On the count of 3, I want that magic word abracadabra. 1, 2, 3, abracadabra. And we're gonna reach right on inside of this bag and I find a mess of ribbon it tied. It worked. Well, we're gonna stick that right on inside of there. Now, of course, that was just a magic trick, right? I told you that I'm a scientist, and that's a fun magic trick. We can, those 4 pieces became tied. I didn't reach in there in time. I didn't have that kind of time for that. Now, I want you guys to think about how that worked, but don't give me any answers, because good magicians, they don't reveal their secrets. So even if you gave me the right answer, I'm not gonna tell you if you're right or wrong, all right? But I want you guys to think about that. But also, I remember asking you guys to think about the difference between a magician and a scientist, right? So, do magicians, they don't reveal their secrets? Do scientists reveal their secrets? Yeah, because they spent a ton of time figuring out how these things work, right? And so today, we're gonna get to be some scientists. We're gonna get to do all sorts of really fun science experiments today, and we're gonna piece together how these things work, all right? So, I think that being said, it's time I moved on. I happen to have something here. Now, are you guys ready for a pop quiz? Because I have a pop bottle here. Now, I have my first question for you, my real question. I'm gonna move this really, really close so you can see it. What do you see inside of this bottle? Does anybody see anything in here? All right, let's see. What does this young lady think? Heather here, you're answering all my questions. What do you think is inside of this bottle? Go ahead. You can go ahead and say it.
Air.
Air!
All around us.
Air is, wow, that was great. Yes, air is all around us. It's really important for us. We're breathing. So if there's a hole in the top of my bottle and there's air all around us, you can feel it there. If you put your hand in front of your face and go, you can feel the air on your hand, right? Yeah, so we know there's air all around us. So we can probably say that there's air in this bottle. So here's my real question now. Who here, give me a thumbs up. Does anybody know how to do a thumbs up? If you look down at the bottom of your page here, there's a reactions button. If you give me, or you could even just hold up your thumbs, but there's a thumbs up button that kind of gives a thumbs up like that. Now, if you guys just want to give me a thumbs up and just like that, that's great too. All right, so thumbs down for a second though. I have the question for you now. If I get rid of all of the air in this, thumbs up if you think it's going to, let's see, maybe collapse. Maybe if I get rid of all the air here, maybe this thing's gonna squish down. Give me a thumbs up if you think that's gonna happen. Or if you think nothing is gonna happen when I get rid of all of the air inside of this, I want you to give me a thumbs down. Oh, you think nothing's gonna happen there. All right, all right. Oh, Catalyst Courtney thinks that this is gonna get flattened out. All right, so let's see if we can get rid of the air inside. You know, there's a great way to get rid of the air inside of this. I'm gonna use a vacuum. And in fact, I'm gonna use the vacuum that I'm built with right here. I'm gonna use my lungs and I'm gonna get rid of all of the air inside of this. Here we go, you ready? 1, 2, 3. Oh, that is some nasty air that was in there, man. But what happened to it? It got flat, didn't it? It flattened out. Now, would you believe me if I told you that the air all around us, would you believe me if I told you that that air all around us had weight? Thumbs up if you think that the air around us has weight. Thumbs down if you think that that's preposterous, totally crazy. Yeah, I don't feel the weight of that air either, right? But you know what? It's really there. All of the air around us has all this air pressure. The air goes way up above us. Like, 50 miles, more than 50 miles, way up above us. That's a lot of pressure. In fact, tell you what, I want everybody to hold up your fingers just like this. Just like so. You can put them right in for you. There you go. Yeah. All right. So I want you to take, get rid of my squished bottle. There we go. Take your circle right here and set it on your arm somewhere, just like so. Inside of that circle is 14.7 pounds of air pressure. Your fingers are about like 1 square inch there on your arm. There's 14.7 pounds of air pressure pushing right down on that. Now, remember that number? There will be a pop quiz on that later. I'm just kidding. I'm just kidding. Now, there's 14.7 pounds right on that. Now, if you look at me, that's a lot of circles all over the place, right? And all of those circles, if I stacked all of those circles right on top of my head, you know what that would equal up to? For every one of those 14.7 pounds, it would be like a full-grown African elephant sitting on top of my head. Now, do you feel like there's a full-grown elephant sitting on top of your head? No. If you do, you should probably see a doctor about that because that's probably not good. Now, I don't feel like there's really a huge elephant. Well, actually, I do feel like there's an elephant sitting on my head. This is Ellie, by the way. Everybody say, what's up, Ellie? So all of that air pressure is not pushing right here, right? It's pushing from us from all sides. It's distributed evenly. I want you to practice saying a word with me at home, all right? I want everybody to shout out really loud at home. I want you to say distribution. So, distribution is when we have everything spread out instead of just being at one point. You know, I'm going to try something here. I'm going to share a different, let's see, I have a different camera here that's going to show you kind of what I'm talking about. So if you look over here, I have all of these cups sitting on the floor here. Now, I'm going to just go ahead and take one cup. I have giant shoes, giant feet. I'm going to step on one cup. Let's see, let's pick, how about this cup right here? If I put all of my weight on that cup, what do you think is going to happen to it? Do you think it's going to stay there? Or do you think it's going to collapse? Give me a thumbs up if you think it's going to hold my weight. Give me a thumbs down if you think it is not going to hold my weight. And if you have no idea, well, I guess wave both hands in the air. All right, here we go. We're going to find out. 1, 2, 3. Yeah. That is one poor, unfortunate cup. That thing did not survive that one. So that's like if we had all of that air pressure pushing right on top of our head, right? But no. This is more like how the air pressure really is. It's distributed evenly. So I have a way, I'm going to sneak over here. I'm going to put this right down on top of all of these cups here. All right. Now, who thinks that this is going to be able to hold my weight? If you think that that's going to be able to hold all of my weight, give me a thumbs up now. If you don't think that's going to hold up all my weight, give me a thumbs down. And if you have no idea again, wave both hands in the air or give me an applause emoji. All right, here we go. On the count of 3. 1, 2, 3. Ah! Whoa! It is holding all of my weight. Every one of those cups right now is holding just a little bit of weight from Jetpack Jason. So now, tell you what, let's see just how strong these things really are. Man, I can kind of jump on this. It's not very springy. It's not really going anywhere. All right, let's do it. They broke. Well, and when Jetpack Jason jumps too hard, then they have a problem. But you guys could see how that distribution works this way. So, here we go. There we go. I see everybody. So it's not like an elephant is sitting right on top of our head. It's pushing on us from all directions. That air pressure is distributed over our whole body, right? Now, I'll tell you what. We can do some pretty fun things here with the air. So I tell you what we're going to do. I'm going to have a couple of these things. Has anybody ever seen these things before? Yeah, you probably have seen these things in like your bathroom, maybe. Yeah, it's a good thing you guys are on that side of the camera today, because these things are really sneaky. I got them out of the bathroom over here just a little bit. I'm kidding, totally kidding. I have only used these one time for a science experiment like what you're about to see. So we can take our two plungers here, right? And we can put them together. We're gonna stick these two plungers just about like so. Now, right here, I want somebody to raise your hand and tell me what is inside of these two plungers as they're put together here. Well, let's see, I'm gonna unmute you here. What do you think? What's inside of there?
Air.
Air! You are absolutely correct. There is air inside of there. All right, tell you what, we're gonna squeeze it now. We're gonna go. Now, what's inside of here? Not as much air. So, since I have those stuck together, do you think that I'm going to be able to pull these apart? Thumbs up if you think I'm going to be able to pull these apart. Am I strong enough to pull these apart? Thumbs down if you don't think I'm strong enough to pull these apart. All right, well, at least I didn't see a whole lot of thumbs down just now. All right, and if you have no idea, go ahead and wave your hands all over. All right, here we go. Are you guys ready? Pull these apart. 1, 2, 3. I'm a little stronger than what I thought I was. Man, that air pressure, it's got nothing on Jetpack Jason. It's because I've been hitting the gym. Not really. All right, woo! Let's try it one more time. Let's see. Maybe I'll just 1, 2, 3. Man, you know what? I just these things, they just can't. They can't hold up to Jetpack Jason. So I tell you what we should do. We need to up our game a little bit here. Rather than using these two plungers here, these are soft. They move around a little too much. So I have something else. I have something called a Magdeburg sphere. Now, this one is a little more rigid. It's not made out of rubber. It's made out of really hard plastic. So I'm going to stick these two pieces together here. And, well, there's a little bit of a fun story about this whole thing. But just know that the guy that invented this in Magdeburg, Germany, which is why it's called a Magdeburg sphere. And it's in the shape of a, well, sphere, which is like a circle, right? A three-dimensional circle, like a ball, right? Now, inside of this right now is what? What's inside of this? All right, I'm gonna unmute you here really fast. Heather, what is inside of this?
Air.
There's air inside of this. You know, I could sit here. You're nailing this. I think it's probably safe to guess we're gonna be doing a little bit of more experiments dealing with air. What do you guys think? Yeah. So I tell you what, instead of me explaining this whole thing to you, I happen to have a nice video here that somebody actually made for me explaining how this thing works. All right, are you guys ready for this? All right, I want you guys to welcome Professor Zoe and Professor Ariana. All right, they're gonna give you guys a little bit of info about this whole thing. Give me 1 second, here we go. All right, here they are. Oh, okay. You know what? I'm gonna pause this really quick here. I think we're having some technical difficulties here. We should be able to hear that. Let's see. Where do I? This right here. Well, let me see. Oh, you know where my problem is? All right. Oh, there we go.
Share screen.
Oh, there we go. Okay. And then there we go. I forgot to click one certain button in that. Awesome. Thanks, Digital Dave. Everybody give a big round of applause to Digital Dave for helping me out here. All right, here we go. Let's see if we can do this again here. All right, now you guys should be able to hear this.
Presented to you by Mad Science.
Give me a thumbs up if you can hear it.
Hi, I'm Professor Ariana.
And I'm Professor Zoe.
Today we're going to be learning about atmospheric pressure. To demonstrate how strong atmospheric pressure is, we're going to be learning about the Magdeburg hemispheres. These are the Magdeburg hemispheres. When you put them together, it becomes a Magdeburg sphere. Right here, as you can probably see, there's a rubber lining. This is so that it has an air. This is because you want to have an airtight seal. As you can see, there is a long tube connecting to
A small vacuum.
a vacuum is something that can suck air out of an airtight container, such as this. So once you put it together and you pump, all of the air will be sucked out of this Magdeburg sphere. It is important to note that the atmospheric pressure inside and outside of the sphere is the same until we apply the vacuum. Hit it, Professor Zoe. With the vacuum applied to this sphere, it is nearly impossible to pull them apart because of all the atmospheric pressure trying to get inside the hemispheres, because there is none inside there. So now we're going to try and pull it apart. Let's go, Zoe. Come on, we can do it. Come on. This is tug of war. Whenever we break the vacuum, atmospheric pressure will come back inside the sphere, and the atmospheric pressure inside and outside the sphere should equalize, resulting in these two breaking apart. Hit it. Ta-da! Yay!
Oh.
This has been a Mad Science Minute with Professor Ariana
And Professor Zoe. Thanks for watching.
Bye.
Bye.
Awesome. How about we give Professor Zoe and Professor Ariana a huge round of applause for putting all that together. They put that whole thing together all on their own. That was fantastic. So way to go, guys. And that's a lot of information there. I was going to tell you guys all about it, but they took the words right out of my mouth. So you guys saw how strong this air pressure really is. The two of them really couldn't pull that apart. And that's because we had, when we do the math to it, like 14.7 pounds, let's just 15 pounds per square inch, right? And there's like more than 20 square inches all over this. You take 15 times 20, you're going to wind up with over 300 pounds of air pressure holding those together there. So that's why the two of them couldn't pull that apart. So we're going to set this aside here for a little bit. And let's shift gears some, because you know, I'm telling you guys about all this air pressure stuff. We've seen we can't pull those things apart. We know how strong it is. And there's actually a way that we can feel the amount of air pressure that we have. In fact, I got to be a test subject for this one on this one. Now, it involves a plastic bag such as this. So please do not try this at home, guys. These leave it to the trained professionals that can do this, all right? Because this stuff right here, we can't breathe through it, right? And we know that we need air to breathe. So I have another video to show you guys here. I was incredibly surprised at how strong this air pressure is, all right? So let's see. I'm gonna show you guys. All I really needed was a vacuum, the air all around us, and that bag. Here we go. All right. And away we go. All right. Hit me! Just in the nick of time. lot of pressure. So really, that was a lot of pressure pushing on me right there. Like, that was, like I said, like full-grown elephants sitting right on top of me. Because all of that air that was inside of that bag, when I first sat inside of it, it was pushing back on the air that's all around us just as hard as the air was pushing down on us. Yeah, so it was equalized. Like, it was, yeah, equalized. I think that's a great word. So when we turned on that vacuum, it got rid of all of the air that was inside of that, which allowed all the air around us to push right down on me. I tell you what, I really honestly could not even touch my own nose. It was that much air pressure, all right? Now, tell you guys what here. I think we ought to try a couple more things that are pretty fun here. But I thought it would be kind of cool to talk about some of the things that air pressure is like, the air can really do with some, well, unfortunately, some damaging things. Does anybody know of, does anybody hear of something called a vortex? If you've heard of a vortex, put up your hand. I want to see if you might know. Let's see. A vortex. That's a big word. All right. So let's see. A vortex is actually, let me give you I'll show you what a vortex can look like here. Let's go over here. There we go. And I'm going to share with you what a vortex can really look like. That right there is a vortex. Anybody ever seen one of those before? Yeah, I'm sure you've seen that. And whenever you let water down the drain, a lot of times you end up with a vortex that looks like that. Does anybody ever, now, vortex doesn't have to be made out of water, right? We're talking about air vortices or vortexes from the air. Does anybody know of a vortex that might form in the air? Let's see. I'm going through and seeing if I see any hands up. What's I'm gonna unmute you, Heather. What's a vortex that might be in the air?
Tornado. And actually, I'm under my mom's thing, so my real name is Breven.
Oh, Braylon?
Breven.
Breven. Awesome. Well, then I'll remember that for you. So, very, very cool. So you said tornadoes, right? Awesome. Yes. A tornado is another type of vortex. And in fact, I have a vortex to show you guys here. Let me see. And this is an even bigger vortex. This is a tornado. It's swirling air, right? And all this air is moving really, really, really fast. It can be some damaging winds. Now, I tell you guys what here. I brought with me a vortex generator myself. Instead of me just showing you pictures of vortexes, in other words, I have a vortex generator right here. Has anybody ever seen one of these before? This will make a vortex. Now, my vortex that comes out of this is a little bit different looking. It's not like the one that you might see in your bathtub, like a whirlpool, or it's not like a tornado. It's not spinning like that. I want you to imagine a donut. This is called a toroidal vortex, by the way, if you want to get all technical about it, right? A toroidal vortex. And it's like in the shape of a donut, and it spins. Now, we can't see the vortex that comes out of that. Did you guys see that vortex at all? Yeah, no, I couldn't either. But we can certainly see the effect because, well, the air is invisible, but we can see what it does, right? Now, guys, I have to use a little bit of fire here. Now, who at home should play with fire? No, hands down. Please do not try this at home. I am a trained professional. I have done this 1,744 times, and I've only burned down about 64 buildings, so doing pretty good. It's a good thing you guys are on that side of the camera. Now, we have our candles lit here. Who thinks that we're going to be able to get our vortex to blow out these candles from, oh, let's say right about here? Raise your hand if you think so. Or give me a thumbs up. Or if you don't think I'm going to be able to blow these out, I want you to give me the applause or give me a thumbs down on your screen. All right? And if you have no idea what's happening right now, well, sit tight. All right, here we go. Are you guys ready? On the count of three. 1, 2, 3. Woo! I think I got it. Yes! Let's up this a little bit. I got to try this a little bit farther away. That was actually the best that I've ever been able to do that. That was some pretty close range. All right, here we go. So we had ourselves a nice toroidal vortex coming out of that. And in fact, I'm going to shoot this one from over here this time. I want you guys to see, maybe you're going to get a glimpse of it as that smoke pushes past the camera here. You may be able to actually see the vortex move along. Here we go. Ready? 1, 2, 3. Woo! Oh, there we go. Oh, can't get the last one. There it is. Awesome. Now, we can, with just this little thing here, that was enough wind. Did you guys see the vortex? Did anybody see the vortex as it was moving through? Raise your hand if you saw it. Awesome. Very cool. I'm glad that came through on the camera. Awesome. So if we have a little bit of air like this that can put out candles like that, could you imagine all of that air in like a tornado? That's why we really need to pay attention to weather reports and take shelter whenever we have like a tornado warning. But you know what? For right now, I'm going to put this vortex away because I know that we are, there we go. We're going to be safe from that one. Now, there's some other really fun things that we can do with air. Air is important for us, right? Like what's something that we use air for? Can somebody put up your hand? Tell me what's something that you might use air for? Breathing. There you go. What might you use air for?
Maybe if you were testing out boats, you could use a baggie and put air inside, like, I know, like, say outside, like, just blowing into it, then seal it.
Nice. Okay. So that's really good. I like that one. Awesome. Let's see. Does anybody else have anything? Man, that was really good. Anything else you might use air for? Let's see. Is that Professor Ariana? Oh, okay, Professor Ariana. Let's see. I'm gonna unmute you. Oh, there we go. What's something else?
Like you could use one of those windmills that could generate power.
Oh, I like that. Yeah.
You can also use it to live and breathe.
Well, we use it to live and breathe. Thank you. Yes, very good, Professor Zoe. Hi. So yeah, you guys are absolutely right. So windmills that generate power, we use it to breathe. Does anybody know, did we ever use air? Oh, Breven's got another one. All right, go for it. One more.
And it's also important for animals that live on the earth, but it's very dangerous for animals that are living in the sea if they're on land, because they get their oxygen from the sea or water.
Man, you got that. Why don't you come on over here and you can tell everybody all about all the stuff you know about air. That is awesome. Way to go, Breven. Yeah, you are absolutely right. Now, the animals that live underwater, they can't breathe air. Their gills are made for only getting the oxygen from the water. Very good. So, tell you what, I'm also thinking about animals that might not just live on land, but that might spend a lot of time maybe up in the air, right? Yeah, I mean, in fact, we as people use air all the time to fly, don't we? I mean, air is pretty important to fly. What's something, Breven, I see you have your hand up already. All right, let's see. Breven, what is something, can you give me something that people have made that can fly? What's something that can fly?
Bird or a bald eagle, and maybe if you try to jump off your house, you will not at all fly at all.
You know what, Breven, that is, yeah, you're right. We should not jump off of high places because we don't have the right parts of our body to be able to fly. We need something like wings. But do we need wings in order to fly? You know, actually, I have something here. I'm going to show you guys something that flies that people have made that because people have always been curious about flying and have come up with all sorts of contraptions in order to fly. So I'm going to share with you a couple of them here. And these are flying. In fact, I think it would be like really cool for us to maybe try to make one of these. Has anybody ever seen something like this before? A hot air balloon, right? So a hot air balloon flies because it is full of, well, hot air, right? And hot air is less dense than the cooler air all around it. And so since it's less dense, it's going to rise, right? It's going to try to float on top of the other air. So I tell you what we're going to do here. We're going to try to make ourselves a hot air balloon. Remember that bag that allowed me to feel all that pressure? We're going to use this. And then I'm going to switch my camera here. All right, we're gonna switch over to this one here. That should, there we go, there's our hoverboard hanging out there. And I'm gonna move this back just a little bit and allow you guys to kind of see a little bit more here. There we go. And this is my awesome launch pad here. And we are gonna slip our bag right over our launch pad, just like so. And there we go. Now, we need a way to get hot air into that. What do you think? I think I have something sitting around here that might get hot air. Let's see, maybe, how about a Mad Science hairdryer? Woo! That is some warm air, yeah. So a hairdryer is gonna blow warm air out of it, right? And that warm air is gonna be very, very, very important to get our hot air balloon full of this air. All right, so we're gonna see. I'm gonna see if I can get a good camera angle here. Also keep this getting filled up with air. So we're gonna pump this thing full of hot air. Lots of hot air. Turning into kind of a ghostly image right now, isn't it? All right, here we go. And then, oh, it's one to take off. It's one to take off already. Ah! There we go, 1, 2, 3. Uh-oh. Uh-oh. Oh, it needs more hot air. There we go. Ah! Oh, I think it got hooked. Even more. A little more. There we go. And it's done. Oh, no. Well, there. Huh. You know what? I tell you what, I am going to call that a successful launch. Now, it didn't quite make it as high as I was hoping, but the ceiling, it kind of didn't help me out there. It wasn't able to get a whole lot higher, but that was pretty high, you know, to launch something inside. So I'm pretty happy about that. Let's see, Braven, what do you got here? You got your, man, you were like answering all my questions. What's up?
Actually, the air escaped it to fill it with cold air, so that is how it is. Or you could just take a hair tie and just like wrap it around the bottom, and then it'll probably launch up. But like you can't do it on the launcher, otherwise it would be like close to it.
I like your thought. So you're thinking seal that thing up so that hot air can't escape, right? Yeah, like you would with like a normal, like a helium balloon. That's actually a really good thought. I like that idea. You know, that might be, I might have to take some thoughts into consideration with that, Miss Breven. You know, we're gonna, for right now, let's move on and try something else. You know, let's think about like maybe instead of hot air balloons, because hot air balloons in here, I just didn't want to go. But maybe something else like what's something else that might fly other than a hot air balloon? Does anybody, let's see, Professor Ariana.
Maybe like a drone because of like the propellers on the little, I don't know, sections.
I like that idea, yeah. Like a helicopter or a drone. That's really, really good. So we can, what we do is we have our, we wind that up. Well, I'm going to wind this one up, but like a drone or a helicopter uses its own power, right? So it blows the air or pushes the air in one direction. In this case, it's going to push this way, right? And it's going to, this thing's going to spin and it's going to deflect that air and go one direction. Yeah, helicopter. What about like just a regular airplane, right? Those things move forward because of, they can use propellers like this and they'll get to going. Like maybe they'll go kind of like something like so. There we go. That went pretty good. All right. Or, you know, maybe one, instead of using like propulsion like that. Oh, let's see. Okay, hold on one second. Professor Zoe has her hand up in the air. What do you have?
Maybe you could also have like a helicopter. I know that has a big propeller.
Yeah, you're gonna want a big propeller there and spinning and really pushing that. And so that pushes the air one direction, and then that gives us the equal and opposite reaction to send something the other direction. That's good. And that's how airplanes work too, is with the propeller. You know, instead of using like propeller propulsion, how about maybe like jet? Like a jet propulsion. That is going to use some power. I tell you what, I brought with me a mini jet here that I can make right here in my Mad Science studio lab studio, my Mad Science place. And we are going to, well, first thing is we got to figure out how this works. We need 3 things in order to get a jet to work. We need 3 things in order to get fire to work. So somebody raise your hand. Give me one thing that we need in order to get fire to work. By the way, who should try this at home? Nobody. Don't try this at home. All right, Breven, what's one thing we need in order to get fire to work?
You need like some rocks or like something so you don't catch the house or wherever you at on fire. That's the first rule that my dad always said.
That's perfect. I love it. Yes, something to keep us safe, right? So let's just use safety, right, for that one. That's really, really good. That's the first step we should take. All right. All right. That's great. I love that. Let's see. Well, there's still 3 things in order to get the fire to go. I'm going to give you guys a hint. It's, well, let's see. Ariana, Professor Ariana, you raise your hand. What do you got?
You need fuel like paper or wood or something, or like rubbing alcohol, sanitizer.
I don't want to know what kind of fuel you're using at home. All right.
Well, we're using wood, okay? It's just highly flammable, so.
Perfect. I love it. So we have here ourselves a little bit of something called ethanol. It is a type of fuel. It is a liquid. And so we're going to use that as our fuel. We also need something else. It's in the air all around us. I want you guys to all say oxygen. Can you guys say oxygen? I am going to guess that everybody just said it just now. Awesome. So then we have one more thing. So we have our fuel. It's inside of this. I'm going to mix this up a lot. Now, there we go. That's looking pretty good like so. And we also have our oxygen. It's in our air all around us. The last thing we need is a heat source, an ignition point, something to get the fire started. This is where the crazy bits happen here. All right, so we're gonna take these and I'm gonna be safe. I'm gonna hold this with a pair of tongs. Perfect. All right, our heat source is going to be a simple little match. Here we go. And now, oh no, don't go out, don't go. Well, that's why I have this. All right, here we go. On the count of 3, 1, 2, 3. Woo! It's still going. Well, that was fun. But that one happened really quick. That was pretty tiny. I'll tell you what, can I show you guys something else that might be a little bit more giant than that? It's a little too giant to sit here on the table and let you guys see the whole flame that comes out of it. So I have another video here that I just have to show you that has the whole thing happen. All right, you guys ready? Let's see, this one's a little more giant. And here we go. I'm gonna share that, and here it is. Now that happened pretty quick. Did you guys, everybody see that? Should we try it again? Maybe we should try that in slow motion. What do you think? Yeah? All right, I have another one here. We're gonna take a look at this in slow motion here. All right, and here we go. So with that, had a lot of heat that was generated inside this bottle. And when we stuck that, when all that heat expanded, made that air, all those gases inside there expand, they came out of the nozzle of that really, really, really fast. And when we have gases escaping like one direction like this, it sends our device, whether it be like an airplane, it's gonna go this way, or even a rocket, something down those lines. Now, since I kind of want to stay safe here, I'm going to let that sit right here. Besides, I can't really put anything more inside of that to get it to launch, because we have a lot of leftover gases inside there, so it's going to take a while for all those gases to come out of here for me to be able to do this again. Now, I got a question for you guys here. Unfortunately, I'm about out of time. I want you to raise your hand if you've had some fun so far with me today. Everybody have fun? I've had a blast with you guys here. I am so glad you guys were able to make it here today. Now, I have to show you one last thing that we can do with air and have some fun with it, all right? Now, please don't try this at home. It might make mom or dad a little upset, right? And also, like, leave this one to the professionals too. I got in really deep trouble for trying this one the other day. All right, here we go. Let me see. I have to, give me 1 second here. I have to change my slides here. Oh, la, la, la. This is my changing slide music. Dun, 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 dun. All right, here we go. We got it. All right, are you guys ready for this? Here we go. We're going to use a little bit of Bernoulli's principle here. Don't try that at home, please. Guys, I had a blast hanging out with you guys. That whole thing right there worked because of something called Bernoulli's principle. So when we have fast-moving air, it creates a low-pressure area, and that allowed that toilet paper to get up into that airstream there. And it definitely helped to, yeah, make a mess of the place, and I had to clean it all up, of course. Now, guys, I want you guys, thank you guys so very much for coming and joining me today. And I want you guys to keep thinking about all of the fun that we had today and all of the stuff that we use science for every day, whether it's air pressure or air, because we use air every day. And I want you guys to think about while you guys are like helping maybe like bake cookies or even turn on a light switch, you're actually doing science, all right? Let's see. Oh, look, Breven, you've got one question here, one more question here. Go for it.
I actually know something.
You know? Okay, you got to tell me.
Air is actually going for everything, even walls and even through your feet even.
Through my feet? What? What? Wow, that brings up to having a whole new meaning to having a light foot. Wow. That's very good. Yeah, air is all around us. You're right. All right. Anybody else have any other questions before I have to sign off here? All right, guys, I want to thank you guys so very much for helping me out today and having a blast. I had a blast with you guys. Breven, you have got so many questions. All right, one more. And then I got to make like a pack and jet. Get it? Ah! All right, Breven, go for it.
How do birds like use air and not really use gravity that's like pulling down on us every single second no matter what?
Very good question. How do birds overcome gravity? That's very good. So just a second ago, you saw that video when we used that toilet paper in here. Well, that's something because of something called Bernoulli's principle. And that allows with the air moving across the top of this, it creates a lower pressure area up here, which means that the air down below is able to push up and give this what we call lift. So as a bird flaps its wings and flies through the air, is it flies through the air, it creates lift with those wings. And that is able to balance out or even overcome gravity, which helps it to either stay in the air or go higher in the air. That was a great question, Breven. Thank you very much for that. Awesome. All right, guys. Listen, I gotta let you go. Guys, thank you guys so very much. I'm gonna give you guys a huge applause right here because you guys were a great crowd with me today. You guys gave me some great answers, some great questions, and I had a blast with you guys. So thank you guys so very much. And always, always, always have fun.